All right, so question C is a bit tricky. It asks if the letters O and I must always appear together, how many permutations of the word diploma can we have? So the letters O and I must appear together. When a number of objects has to appear together, it's easier to treat those as one object or one unit, okay? So you'll see, right, we have the letters D-I-P-L-O-M-A. Let's treat those, the I and O, as one object because they always have to be together. Then we have 1, 2, 3, 4, 5, 6 objects that have to be arranged. Okay? We know the number of arrangements for n objects is n factorial. So 6 objects is 6 factorial. But what we also have to consider is we could either have an OI wherever it appears together or an IO. So we also are arranging those two objects within that one object. We're classifying that as one object, but it could be always IO or OI. We're still rearranging those two things. So there's 2 factorial ways to rearrange those two things. In a question like this, we need to multiply those together. So it's 6 factorial. So it's however many objects you're arranging, factorial, multiplied by, if you grouped an object to be one unit, grouped objects to be one unit, multiplied by how many ways you can rearrange those. Okay? So if we do that on our calculators, we should get 1440. These questions are trickier as well. When objects must be separated, it's easier to do all of the possibilities, subtract what you're not looking for to get what you are looking for. In this case, it's easier to do the total number of ways we can rearrange diploma, subtract, if we subtract from the total all the ways O and I are together, we will be left with only the outcomes where O and I are separated, only the arrangements where O and I are separated, right? This is easy. It's called an indirect method because we're not just calculating this, we're trying to calculate it from subtracting what we don't want from the total. That's called an indirect method. But it's easy because we already calculated these two things, right? We had the total up here was 7 factorial or 5040. Subtract all the possibilities O and I appear together, which was here, 1440. So using that indirect method and calculating, we will have 3600 arrangements where O and I are separated. Okay? Last page, some more examples. So it says a used car lot has 10 cars to be sold. 10 cars to be sold. That's probably going to be our N, right? However many we're picking from. Because 4 cars are to be arranged for display on the front row. In how many ways can this be done if there are no restrictions? So 4 is going to be our R. We're picking 4 cars from 10. Okay? So if there are no restrictions, again, we're doing 10 cars and picking 4. Let's put that in our calculator. So 10 pick 4 equals 5040. Perfect. All right. So the only car with a sunroof must be used at the right end of the display. Okay. So in this case, when one thing is fixed in a position, it's easier to figure out the calculations by setting up your different stages. So we have 4 cars, 1, 2, 3, 4 cars must be arranged. Car 1, car 2, car 3, car 4. For car 4, we know at the end, that's the end, it must be the car with the sunroof. So there's only one choice. right? So that means for our first car, well, we already used one of the 10. We only have 9 choices left. Then for our second car, only 8 choices. Our third car, only 7 choices. Okay, so that will be our calculation there. Let's put that in our calculator, see what we get. 9 times 8 times 7 times 1 equals 504. The only car with a sunroof must be used anywhere in the display. Okay, so a new situation. The only car with a sunroof must be used anywhere in the display. The easiest way to go about this question is do another indirect method. So we're going to take the total number of arrangements, subtract the number of arrangements where the sunroof car is not included, and we'll be left with the number of arrangements where it is included. Okay, so we already calculated the total number of arrangements. It was 5,040. We're going to subtract off the number of arrangements where the sunroof is not included. That's actually the next question. So let's do that one first and use that information back here when we need it. So the only car with a sunroof must not be used in this display. Well, that would mean we're picking from only 9 cars, right? There's one of the 10 cars we can't use, but we're still picking 4. So the question changes from 10 pick 4 to 9 pick 4. Because we can't even touch that car with the sunroof, it's not really even in our total to pick from. If we put that in our calculators, 9 pick 4, we get 3,024. Now we can sub that back in here. 3,024. So 5,040 minus 3,024 equals 2016, which is the answer there. Okay, so now you are responsible for working on these practice problems, this page and this page. And next lesson we'll pick up arrangement of objects when some are identical. See what we have to do there. Don't get too hung up on this stuff. Just remember these things, okay? So remember how to set up your stages. How many choices do you have at each stage? Is something fixed? Does that change the number of choices at each stage? Is one object stuck in one spot? Looking at your pick notation, okay, or your pick formula. You would use your pick formula if you didn't have a calculator handy. Even if you didn't have a calculator with a pick function, you could always resort to this if your calculator has factorial. And remember tricky situations, right? If 2 objects or more must be together, treat them as one unit, count that as 1 plus the number of remaining objects, do factorial, multiply it by the number of ways you can rearrange the unit. All right, so it's going to be the number of objects in that unit factorial. If it's separated, a question like it's separated or the number of arrangements where we can't have something, do the total minus the, sorry, I said that wrong. So here, we want to use an indirect method, doing the total minus what we don't want to get what we want when objects are separated, or over here, when an object must be in the arrangement, it's easier to subtract the number where they're not included from the total. Okay, so those are 2 situations where we use an indirect method. Okay, so good luck. Give those questions a try. Bring any difficulties to class on Thursday, and I'll be able to help you out.